In the previous video, we talked about the definitions, the purpose of face. Now we talk about the purpose and types of core. Alright, and therefore, let's go on to this page. Alright, so similar to the facing, alright, which is the red color one, the face, there's two faces and one middle core, right? So therefore, the core itself also stabilizes the facing, alright, meaning it allows the facing to give it a support, alright, more on the supporting, because it support the facing against buckling and bending, alright. So it helps to support the bending, alright, because you increase the height of your material, so therefore it will helps in supporting the bending issues, and also because you make the overall thickness of your materials to be kind of thick, so when you have certain forces acting in this thing, alright, it will not buckle. Alright, the buckle, if happen that you forgot, is like this. So if you were to buckle, you'll move something until like this. So buckling is similarly like a bending type of thing. So therefore the core itself acts as a support, alright, to prevent buckling and bending to occur. Alright, and it provides shear strength and crush resistance. So what are they? Shear strength, I believe you know, because it's trying to prevent any shearing to occur either in this direction or in these directions. Alright, it's just pure pure shearing protection, that's all. Alright, while the crush resistance, to a certain extent, if you have a certain paper and then you try to crush it, alright, so paper is very easy to crush, right, and it becomes so-called creased, right? So so likewise, the crush resistance means that is a good resistance against crushing. Alright, if you were to have a very big impact force against all of the sides, alright, it is more in resistance against this type of crushing in all directions. Alright, so in a more definition way type of thing is the crush resistance is not being easily creased. Alright, if happen that you want to know. Alright, and crease is this type of thing. Alright, it's very jiao. Alright, it's this lines all over. It's very tough to, yeah. Anyway, so it provides this type of crush resistance. Alright, and I think no need to explain already. This is quite straightforward. Insulation may be heat insulation, maybe electrical insulation. So you may want to take note. Safety, no need to explain. Adhesion must be good. Alright, so the core surfaces also must be good for adhesions, so that it can adhere well together with the face, so that the adhesions give you allows you to make the whole sandwich structure to be like similarly like a one structure, that's all. Alright, and the core thickness requirements, things like that. So the core mainly itself is quite kind of an important issue over here. All in all, you may wonder what is sandwich panels for. Alright, and therefore sandwich panel over here, then it says that it's a very efficient way of providing high bending stiffness at low weight. Alright, so it's a high bending stiffness against low weight. So if you want a material that is low weight while having high stiffness, then you're going to choose a sandwich panel composite. Alright, so this is again another definitions. Alright, this is for the facing, it carries bending loads. For the core, it carries a shear load while also supporting certain bending loads. Alright, and the principle is the same as a traditional I-beam. Alright, the I-beam is something like this or something like this. So high bending load requires one skin to resist in compression and the other in tension. So I believe the I-beam itself, alright, over here is resisting compression, alright, because of this section over here. Okay, while over here, alright, it resists a certain tensile pulling, or because of the long thing over here. Alright, so if I were to draw it to flip it like this, alright, seems like a H now, but anyway, so over here it can resist compression, and over here it can resist the tensile, and this is what it's trying to say. Okay, because when you pull it, alright, this part over here is very long, so it can resist a longitudinal so-called strength, right? If you remember, your fibers is a long fibers, and then if you were to pull it, it's pretty strong in this direction. Alright, it's the same analogy. Okay, and over here, if you were to compress it, because of this structure over here and this thing, trying to compress and buckle it is pretty tough in this direction. and hopefully it kind of rings a bell for you. And hence they will have to be well bonded. So your sandwich panels must be well bonded in order to have something like a one structure. So your sandwich panels the facing and the core must be well bonded so that it is somewhat like a same material altogether. Alright, because we know that the face and the core are two different materials, but if you were to adhere them or stick them together very closely or bond them together well, or they are just similarly like a one material already. Okay, and therefore let's continue with the core. So therefore there is three types of core. Alright, they expand these three types. Okay, and we'll go into details now. We'll mainly focus on the honeycomb core. Alright, and if you were to just keen what are they, just go through is the expanded plastic core is just simply a piece of plastic that expands the core. That's all, finish. Alright, so the honeycomb core is slightly more cheap, or it's more on it's safe material, will also provide a good so-called compression strength in that. Alright, because of the hole over here. Alright, so this hole over here all around provide good compressive strength. Alright, this is what the honeycomb is, and corrugated core is just this core over here. Alright, and also helps to resist a certain so-called bending issues. Alright, in a way, yeah, but I don't go into details, but mainly focus is the honeycomb core, and therefore let's talk about the honeycomb core also. Alright, and going into the honeycomb cores, alright, the honeycomb panels, let's talk about the type of core first, besides the three types. Alright, so these three types are very common. Alright, and expanded plastic core, one of them is actually the polyurethane foam. Alright, so the polyurethane foam is something like this, alright, like your sponge. Okay, so this is the polyurethane foam. Okay, hopefully this is pretty clear. And therefore this is a form of a expanded plastic core. It's form of plastic, but in a way that it is it also uses less material as it's expanded to a certain extent, right? Anyway, so the density, compressive strength, everything all over here, these are the standard things. So sometimes they would ask you what are the different properties for choosing the type of core. So one thing is that you would want to also know how to this 5 properties, and also to able to choose the type of properties that you want for your particular panel. Alright, so the exam will give you certain requirements, and you will have to choose the different properties and to choose your best balsa wood or aluminium or whatever it is. Okay, so if you want the highest modulus of elasticity, meaning Young modulus, then you're going to use balsa wood, which is very stiff. Or high Young modulus is a stiff material, so therefore you will use balsa wood. Okay, and if you want to compare it with maybe your density, then you will have to compare with the density and see what are the differences. Maybe you will want to use in the future you may want to use digital logic method, alright, or weighted properties method to help you to select the materials already and things like that. So you'll go back to other stuffs. It gives you a understanding of how to choose a material, or most importantly how to choose the type of core of the material of the core. Yes, and honeycomb panels. Now let's talk about honeycomb, because as you can see, honeycomb is quite of a big issue in this space. It's widely used and it's very powerful. And excellent strength to weight ratio means that it's very high strength with low weight. Alright, high strength with low weight, that's just the meaning. And the rest I think is pretty straightforward already. But this sentence, alright, is a bit weird. The honeycomb structure increase the beam strength of the solid composite. Okay, it's nice, very nice. And then aircraft paper used in deck floors of marine. So in the deck floor of marine vessel, honeycomb structures are used, alright, for composite and craft paper. Is it that meaning? Yeah, most probably. So in marine vessels, alright, for craft paper and composite, they use honeycomb structure, and this is what they're trying to say. So craft paper, if you think about it, is this type of paper, alright, it's like your recycle back paper type of thing. Yeah, craft paper is kind of easy to I don't know whether is it easy to create a honeycomb shape, but it's certainly not resistant to water. Alright, so be very careful about that. Alright, and after knowing the honeycomb, so we'll only talk about the honeycomb now. And now we come back to talk about expanded plastic core. Alright, where it talks about the foam cores. I will believe is the expanded plastic core. Alright, so honeycomb core we somewhat talk about it already. Now talk about this. Corrugated core, I didn't see anything about that, so I don't think we are talking about it anymore. So our focus is only about this two now. Alright, sorry about saying that we only talk about honeycomb. Alright, so now in fact we are talking about both of them now. So the next coming up is the foam cores, or your expanded plastic cores. Alright, it's a typical applications, and so a traditional PVC type of foams are closed link thermoset. Or if you remember the closed link, so it's actually under your page 95 of your lecture note part 1. Alright, and it's actually called cross link, not close link. Alright, I think there's some typo error over there, but the cross link itself is pretty strong. Alright, so therefore for example, the linear polymer is that you have these lines over here, and if you were to push the first line, as you can see, if I were to push this thing, alright, meaning the first thing, as you can see, if I were to push it in this direction, alright, it became here, and the rest of it will follow quite steadily. Alright, however, a cross-link polymer is different. It's kind of much stronger because it holds the chains together from these points. As you can see, these are all points. Over here, the points are not cross-link. Alright, they are not cross-link. So over here they are cross-link, so therefore their bonds are somewhat kind of strong. So they are somewhat pretty much elastic, because the chain can be stretched while cause them to flow past each other when released. When released, the polymer will not return to its original form. Oh great, it's not elastic. But anyway, it's somewhat like a good bond to a certain extent, if I never remember wrongly. I would suggest you watch V3.1, alright, introduction for thermosetting, alright, or you can search for V3. Sorry, I should say V3.8. I don't know what I'm talking about. Yeah, it's a linear polymer, it's thermoplastic, crosslink is thermosetting plastics. Alright, the information is somewhat at about the 6 minutes.
We're linear,
as you can see, so you can own self see about it. But I just want to make an correction, is that cross-link polymer, alright, is never stronger than linear polymer. It's just the different applications. Okay, it's just the different applications. So don't mix it up, which I've said. Alright, so therefore the cross-link, alright, thermoset makes them unyielding, but may fail in later life under stress, and so on and so forth. So yeah, you just need to know that your foam cores, alright, are thermoset materials. Alright, so it will not deform under certain heat. Alright, once it will just break, but it will not deform. That's just the meaning of that. Okay, and while the other foams in the recent foams, they uses the polypropylene, which is a thermoplastic materials. Alright, so thermoplastic materials are linear. Alright, they are linear, so I don't think it's a closed cell type of thing, I don't know, but there is a difference. As you can see, the linear is this linear polymer, or the cross-link is this cross-link. So in the past, we traditionally use the PVC, which is a thermoset, alright, which is a cross-link. Now we use a polypropylene, which is a linear chain thermoplastic. Alright, so what is the difference is that your PVC or your cross-link thermoset, alright, is to resist under stress and shear stress and by cracking, to prevent any cracking. What am I talking? I'm killing myself. Okay, my fault. Alright, so the PVCs allows unyielding. Alright, so it prevents deforming. Alright, so it can allow the shape to be there. Alright, but it will fail across certain time. Alright, for PVC. Alright, for PVC, it doesn't deform much. For the polypropylene, which is the thermoplastics, alright, they are useful when shocks, fatigues, and severe dynamic loads are expected. So if you don't want your things to be deforming, you use your PVC. If you want to have shock resistance, fatigues, or whatever, you can use the thermoplastic, because thermoplastic is more on the elastic side, I believe. So or I don't think it's more on the, I don't know lah, but at least it takes in more energy, given that it is a higher fatigue load. Alright, things like that. Alright, and I think you can know more about this. You don't need to go through. Yeah, so the foam-filled honeycombs are combinations of a foam with honeycombs. Alright, so it's a combinations between these two. Alright, plastic core and a honeycomb core, they combine all together, and therefore a foam core, so-called honeycomb, I believe is this type. Alright, so they are the honeycombs are formed while they are connected with small joints, as you can see, small joints. So the small joints happens at these joints over here. Alright, so these are the just small joints. So they are all so-called foam core, meaning the foams are in the shapes of honeycomb. And therefore it's called foam core honeycomb. And this one also, I believe, foam filled honeycomb. Okay, and the next thing you may wonder is, this is the foam core honeycomb also. Alright, hopefully you can see they are all in terms of honeycomb shape, but they are foamed. Alright, instead of empty honeycomb, alright, all of them are filled with some foam, alright, some plastic, and this is the foam core honeycomb. And yeah lor, so it's used in boat constructions, as shown in the right figure, which is this figure. So as you can see, if I zoom in this figure, alright, as you can see, there is no hole, or there is no hole. They are all so-called plastics. Alright, they're all plastics, and this is the meaning of that. Okay, and I think this is it for the core. Alright, with explanations not very good, but at least give you a full understanding of all of them. So yeah.